Hi everyone, thank you for joining this training today. So the first thing I would like to explain you about JAKA robot. The contents will be having two topics. One is a JAKA company products and second is a JAKA advantage and complement. JAKA Robotics was founded in 2014 and we have the business coverage over 100 countries around the world and we have over 10,000 cobots installing in customer location. And currently, we have an office in China, Japan, Germany, and Malaysia. Our mission is Free Your Hand by JAKA. For this page, it will tell you about the growth and expansion of the JAKA business. The significantly in growing business happened on around 2018 when we have the finished Series complete round A investment and Series B in funding. And we deploy the branch in Shenzhen and service team in Japan. And finally, in 2025, we established the new production line based in Nagoya, which supplying the cobots to Toyota Group sites, Aisin, Denso, and others. For the JAKA product line, as you can see from your left-hand side, the standard product is called Ju Series. 6-axis cooperative robot payload. We have 3 kg until 30 kg which have such launch and precision up to 0.02 millimeters and reach up to 1.7 millimeters. For the AI series, as you observe from here, the cobot itself is the same product, but the AI series will come with lens 2D camera and controller supply as minicap. The controller supply as minicap is a mini controller that can support DC power supply. So for the JAKA S series, it's a built-in high accuracy force sensor. So it means that as you can see from here at the end flange of the cobot, you will see the force sensor attached on here. So it means that we can use the forwarding control forwarding apply at the end flange, like how for polishing application and how Newton meters we want to apply to the workpiece. And IP protections will be up to 65. The Jagami Kobo currently we have 1 kilos and 2 kilos already for the lightweight and high performance, perfect for education and retailing sectors. And another product we call Jakapo series. Jakapo series is the one of the highest waterproof and dustproof protection cobalt in the world. Currently we have IP68 and payload up to 16 kg. And the next product is a Jaka VPS Vision Protection System, the safety camera that monitor people object to ensure the safety to the robot and people. And Jaka Lens 2D is a camera for positioning, barcode, QR code, recognition, color detection, measuring. And for this product, we available have two type. One is a 8 millimeters and second one is a 16 millimeter for lens focusing. And as you can see from here, we have the more than 200 core patterns certificate, which inform us that we can pass SDS 15066, the cobot certification from the TIRA, from the SDS, and MTBF over 80,000 hours. JAKA advantage. If you have never used JAKA before, I would like to recommend to try one at your our local region partner. So basically on here on your left hand side, JAKA cobot Normally in the JAKA controller, we will have the Wi-Fi router, which will generate the Wi-Fi and let you connecting the cobot by Wi-Fi. So it means that there is no need for teaching pendant, and you can use iPad, tablet, laptops to connect to the cobot perfectly. The second one is a safe corporation collision protection system. We have the very advantage point about this feature. The cobot will immediately stop when someone hit the cobot. And this is a drag and graphical programming. The JAKA cobot have designed for education terms and operator who have no engineering background. So it means that it's very suitable for someone who have no programming skill to do the programming to deploy the cobot. The next is plug and play quick switch. Plug and play quick switch is because our JAKA cobot is very thin and light. So it means that when you want to deploy the cobot, you can do it within half day and doing the programming very fast. Finally, it's an open software and a hardware ecosystem. So our JAKA cobot open the software like SDK, Python, C Sharp, C++, or the TCP/IP open protocol, including the communication like Ethernet IP, Profinet, and Modbus TCP, Modbus RTU for free. Everything is free, even though our application is also for free. And hardware ecosystem like the keepers, we have plenty tools partner and camera partner that we can work perfectly with. And here is a JAKA ecosystem that you can see. For the first thing, we call it sensor like 2D vision, 3D vision, and force sensor, and effectors, in effectors like the electric keepers, quick tools, and vacuum keepers. And next is mobility like AGV and MRs. So here is a JAKA standard. The first thing we always say is our strict production process. High precision, that's free productions. So it means that we can guarantee that every cobot that going out from the JAKA factory has been run over 22 hours to confirm the cobot condition is in good condition. Even inside our factory also have the many testing room like the silent room to measuring the noise, the temperature room to checking the high temperature condition. Our JAKA Suite commitment reliable international teams office in multiple locations, online support 24/7, and JAKA Academy. That's all. I will go to the next slide. For this PowerPoint, we will talk about the hardware introduction of JAKA robot. The content topic will be introduction to installation, the introduction of the cobot, and cabinet introduction to the control stick. Introduction of the installation. So basically when we want to unpack the cobot, when you receive the JAKA cobot, right? The first thing you will understand that basically we will have only the cobot itself. We will not provide the robot base for you. So it means you need to design or purchase the robot base by yourself. And then this one is called robot cable connection. The robot cable connection will connect to the JAKA controller or we call cabinet. And the next is a remote stick. Remote stick cable. So as you can see just now this is called remote stick. And then when this is button to power on, and then we check the Wi-Fi hotspot. And then you see some Wi-Fi that generated from the controller, and you can access to the JAKA app. Or nowadays you can access by the web browser. And type down the password JAKA admin. and then you can connect to power on. Power on is mean supplying the power to the robot arms, and enable is mean release the brake. As you can see just now, the cobot have a little bit checking when enabling is normal, since our cobot need to calibrating itself every time after enabling the cobot. And here is a screw type of the mounting the bones to mounting the robot base. And here is a Ethernet interface port and heavy load wire interface, the power supply, the switch, and control stick interface. So basically, when we want to control the cobot itself, as you can see, we also can connect the controller to the Wi-Fi router to strengthen the Wi-Fi signal. So it means that if you think that the Wi-Fi signal of the JAKA controller is not strong enough, so you can connect to the Wi-Fi router to increase the Wi-Fi signal. And here's a recommend Windows, Android, and iOS. So basically, we recommend the Lenovo small new pad or the Xiaomi or Redmi. But for the iPad itself also we can support as well. You can download the JAKA app inside the Apple Store. For getting this file, you can request to your regional partner. So this is a joy of the JAKA cobot. Joy 1, Joy 2, Joy 3, Joy 4, and Joy 5, and Joy 6. And here's an indicator at the end fang of the cobot. So at the end fang of the cobot, around here you will see the robot indicator will show up on here. We call robot end. The end indicator light and pause button. Blue is mean power on, but not enable yet. Green is mean enable. Prepare. Green is mean enable. Ready for running the program. Red is mean have something wrong. Default. Yellow is mean free drive mode, and flashing yellow is mean pause. And at the robot end, you will see the free drag button and point button. The free button is for free drive mode, so it means you can push this button and dragging the cobot around, and point button. So if you push this button, the point will generate inside the software program. And every JAKA cobot will have the GIO at the robot end fang. The GIO, what is the purpose of this one? So basically, we have the configurable NPN PNP type of the digital input output, including the analog that you can use at the GIO. The JAKA controller. The JAKA controller is we call this one control cabinet. V version 2.1 deno port. As you can see from here, we have write down P10, P9, P8, P7, P6, P5, P1, P2, P3, and P4. P1 and P3 is for the digital input, PNP type only, and effective when we get the high level effective. So it means that, as you can see from here, the number 9 until 16, so it's write down at VPass. VPass, so it means it's 24 voltage. If you supply 16 to 1, so it will consider trigger the digital input. And for the digital output is P2 and P4. So P2 and P4, as you can see from here, is write down at 0 V minus, so it means it's 0 voltage. So when you want to make the circuit, so it means you need to working 1 until the resistance and then going to 16. as you can see, V plus and V minus. V plus on here is mean normally when you receive the cobalt, you will see the jumper at the P8 and the P7 at the middle on 3 and 8 pin. So it means that normally it's 24 voltage and 0 voltage. Internal power supply will generate to the digital input output. So it means if you want to use the PLC external power supply voltage to make it like a common in your external power supply voltage, you can plug out the jumper and then supply 24 voltage on V plus and supply 0 voltage on V minus, and then all the digital input output will use the same command as your external power supply, including the emergency button, emergency signal, E, I, and SI is emergency signal and protective signal. Emergency signal will consider to power off the cobot. So it means it will cut the power immediately after it had not been connected. So it means that as you can see the jumper is let the V pass the 24 voltage supplying to the emergency all the times. If we pull out the jumper, so the cobot power will be cut and the cobot will cannot be moved. And for the positive stop, the power still on, but the cobot speed will become 0. So it means that the cobot cannot be moved, but the power of the cobot still on and base still released. We call PX safety function and internal power supply voltage. And P9 is a USB port. This one is for only JAKA supporting, cannot be used. And P10 is for JAKA support as well. It's a fixed IP address 10.5.5.100. And here is a method how you gonna connect to the digital input output. Hmm. And here's a method how to connect to the emergency and protective stop wiring diagram. Another controller we call minicap is very small, like the half of A4 paper. And you can supply the DC voltage. Normally, typical application that will be used minicap is MR or HV application which have the battery supplying 48 voltage or 36 voltage supplying to the minicap. And for the minicap itself also have the signal indicator to the cobot. On here, as you can see, 1 until 20, there's a marking down from here that you can come and see which signal you want to use. And for your information, the minicap base is a NPN type, not PNP type. And minicap itself can be master for IS485 and can be slave for IS485, but the cabinet cannot be slave of IS485. So it means 485 on here on P7 is only for extend being the master to controlling like the keeper or other device, but it cannot be slave. And at here is a power supplying, and here's a method how to supplying the voltage DC only. When you want to set the power supply, it's very important that you know the cobot peak power. Otherwise, when we supplying the not enough power supply, but the cobot will be cut. The first one, the two three, the first one of the two three is a 1000 watt. for 48 voltage, and this one is a need to use 2000, and this one need to use 3000. For the mini combo, normally normally mini combo we will generate the power supply. We will give the power supply to customer, but for the 2 series we will not give the power supply to customer. For the mini combo, the power supply is only 24 voltage and the watt is 280. If you want to increase the power supply, you can increase until 36 voltage for the mini combo and watt being 360 watt. And here is a jumper and default of the mini controller mini cap. And this is a emergency stop button for the mini cap. So it means that if you want to use the protective stop by hard wiring for the minicap, you cannot be used. You cannot use. You need to use the other protocol like Ethernet IP, Modbus, or Profinet to controlling the the minicap protective stop, or use the hard wiring, but you need to use a configurable protective stop. And here is a method how to power on the controller and how to supply the remote power on off the controller without using the remote stick. Before you powering on the robot, every time you need to confirm, every time you receive the new robot, you need to confirm that when you're using the minicap, right, we need to check the resistor start voltage correctly. As you can see, for example, the usually will use 48 voltage. So it means it need to supply, you need to write down 51 voltage here and then click OK before you power on the robot. Otherwise, you will find some error. And same as the cabinet, same as the normal size controllers, there's a two LAN port. The 10.5.5.100 and another LAN port is dynamic. Only obtaining IP address you can change to be 192.168 something depending on you on LAN port number 2. And basically the Wi-Fi name is will be called the cap something, which you can change the Wi-Fi name or the password later. And here's method how to set up LAN 2 the LAN 2 IP address. And for each button, this is a concept how to use the button perfectly. So I would like you to comment to try every button before you using the JAKA code. Basically, there is a light indicator on the remote stick around here, and there is a lock button here. So every time you want to use other button, like home, power on the robot, enabling the robot, start, stop the program, pause and resume the program. So it means you need to unlock this one first. Otherwise, you cannot push this button. Thank you. And here's the next page. Preparation before enabling the robot. So every time you go on receive the new robot and then you power on the robot for the first time, you need to confirm the mounting method that you did to the cobot itself. The ceiling mounting, the side mounting, the base mounting, So you need to confirm this one before you power on and enable the robot. And every time you're using the cobot, you need to confirm the payload and CG, the center of the mass, to confirm the cobot payload is correct. And how we can calculate the CG? So you need to observe the tools, the TIO connectors on the end fans. This one, and TIO connectors will indicator to the X path. You see X path, and on your right hand, your left hand lose the you will see the Y path direction and Z directions. So it means that this is for your example only this keeper the payload is 0.8 and center of mass, as you can see there is no X and no Y, and then it will be only Z direction 80 millimeters. You must set the robot payload correctly, otherwise you will find some error happen when using for long times. The central setting, we have two types. The one is a setting manually inputting, and another one is inside the programming. Why we need to have the dynamic central setting inside the programming? Because some applications like palletizing, pick and place, machine tending, so it means that the payload always change, will be always change. So it means we also need to set the payload. This payload consider the keeper and the workpiece including together. So it means the keeper is 2 kg, the workpiece is 5 kg, so totally is 7 kg, and centroid you need to calculate. And here is another way to calculate the centroid setting. You also can generate the centroid data from the SolidWorks. Why the centroid is very important? Because normally usually our AV models of our JAKA cobot, AV cobot will provide you the offset charge. The offset charge is what? So basically the Jyoti can hold the 3 kg payload. But if you have the object and tools that exceed the probably 200 millimeters, you will see that the payload reduced until 2 kg. So it means that even though the Ju3 payload is considered 3 kg payload at the entrance, but if you make the keeper so long and the centroid is very far from the keeper, so the payload that acceptable will be reduced until 2 kgs. And here's all the payload. Set up the robot limit for the safety setting. So every time you want to use the cobot, you need to confirm that the safety setting you select correctly. You select has been set correctly. So as you can see, the form limit, momentum limit, TCP limit, power limit, stopping time, and stopping distance that you can set. But for the quick setup, you can select like strict, general, and relax. And minimum. Minimum is mean not sensitive. Strict is mean sensitive. For the force, momentum, TCP, everything, if you push it at very high, so it means it will not sensitive. If you push very low, so it means it will sensitive. Before you enable the cobot, this prompt message will coming out to let you confirm the safety setting, the payload that you're gonna use correctly. Thank you. The manual operation of JAKA cobot. So when you use the JAKA cobot, you will see this page, the manual page. Why we call this one manual page? Because normally we need to control the cobot either by feedbacks and by jogging. So as you can see, this one called virtual jogging of the joint, and Cartesian. This data we call Cartesian, and this data we call joint data. So every time you want to move the cobot, you will see that there is two coordinates. The first one is at the infant, the second one is at the world at the base. So at the world at the base, you can see that when you want to move in z direction, the blue color, and clearly you are selecting the world coordinate at the world coordinate. So the cobot will going up following this coordinate. But if you swap to the infant and then move z into past direction, so it means the cobot will go down following this direction. And you also need to confirm the speed before moving. And this is what I'm talking about, the infant coordinate and world coordinate system, or we call this one PCP, and this one we call user frame or works. In other robot bands, it might be called as work area, and this one we call tools. And here's a method when we want to control the cobot. And for this page, this is the two coordinate system switching. So basically, you will see that currently we are using the user frame, and then we will select the PCP. You will see that the coordinate system has been changed to refer to this coordinate. And when you want to applying the actual coordinate or data, like we want to apply the data inside x, y, z, I, x, y, z, the Cartesian data, you also can click inside and then click the data to get inside and then applying from here. If you want to change choice 6 to be 0, and then you also can do it. And then you can move by choice, move by linear, and then you can move. You will see the cursor moving the joysticks only because we are moving by choice. And when we want to change some data for the z direction of the Cartesian, we also can see that if we select the data, you will see there's no movement because we need to click this button first to generate the blue color cobot. Then you can move to the point. And click this button and then move to the point. As you can see from the video, we call this one singularity. The singularity, every robot will have the singularity is the point that the cobot cannot be moved to, because this is a case that we showing that singularity with the cobot cannot pass through the base itself. You see, it's called singularity. So when you want to operate the robot, you need to avoid the position that will make you see the issue of the singularity. Thank you. The next is a check version method. The check version method basically the JAKA cobot. You can connect to the cobot from your right hand side here, and then you can apply. After you connect the Wi-Fi, you can type down the selected cobot and then type down the password. JAKA admin here, and then you can connect to the inside, and then you click this button, the eye icon at the bottom right corner, and then you see the software version here. The first version will show you is a app version. App version is the program version that you're using on your laptop, your tablet, your mobile phones. The servo version is mean the robot arms version. So basically inside every joint of the cobot, it will have the MCU, the memories keeping inside, so it means there is a version need to be updated. HDB version is a motherboard. Inside the controller will handling 24 voltage and other host by inside the controllers. And controller version is the main version that we need to consider when we want to upgrade. Is when we want to have the new commands, the new software, and then you need to upgrade this one. And updating all the version servo SCP the app accordingly to the controller versions. And you also can see the robot numbers, the robot serial number here, and also have the button to check for the update. Updating process. When we want to updating the controllers, the first thing we need to updating controller, so select the files and then click here to update. But before that, you need to disable and pull off the cobot first. The second one is installing the new app, because after we updating the controllers, the new app must be using. Otherwise, it will have the bugs when you generate the program. The next is update the SCP. So we can update the SCP. Select this one. The letters after this training sessions, I will provide you the link that there is a folder inside indicated to AV software files that you can use for upgrading. So the first one is controller, installing new app, upgrading the SCP, upgrading the servos, and upgrading the servo SCP in 2.5 controller. So basically, if you're using the old version like 1.5 app version, you will see the separate page that verifying the SCP and servo. But nowadays we are no longer using the 1.5 app version. And here's method how to downloading the updating package to the list, and then you select this one, select the button, and then find the package, and then after it's finishing uploading, and then you can select the button number 2 to updating the controllers. But know that make sure that your current controller version is 1.5.13.32 or later before updating to 1.7.1. Otherwise, you will find the issue. So it means that for my recommending, if your controller is very old, you can updating to 1.5, 1.7.0.46, and then you can update to 1.7.1. And if you want to updating to 1.7.2, you need to updating to 1.7.1 first. Otherwise, you will find the issue. And before that, please uninstall the JAKA app or version if you don't want to use it anymore. And every time after you want to open the JAKA app, please allow the permission while using run as administrator while using the JAKA app. Here's with the method to updating the SB method. For ensuring the SCP version can be updated, you need to confirm the current SCP version must be higher than 2_55 version before updating, otherwise it will damage the board. The server version, so it means that we want to update the cobalt server version, you will see that there's a mention to C4A series. And if you want to use a mini cobalt, you also need to find the package for the mini cobalt. You cannot mix it together. Thank you. Next, we will talk about the user coordinate. The user coordinate. The user coordinate is considered the method to enhance your application to make it easier to teaching the question, to make it easier to solve the issue when something wrong to the work table. So basically, when we consider the work coordinate system app here, you will see that sometimes your working pane is not quite straight. So it means there's an incline here, and then you want to make a new user coordinate for let the cobot following this coordinate so it can move it to the point easily. So basically you need to come to operation setting, the user coordinate, and then you will see the XYZ, and this is the normal base user coordinate. And on here you will see that they are using your right hand rules to controlling to indicate the directions. And the method to generate the user coordinate, there is two methods. The first one is inputting the data manually. So I would like you to try it by yourself by inputting the data. And the second one is teaching key points. The first point is the origin of the new design user coordinate. The second point is any point in positive direction of the x-axis. So it means that it will generate the x-axis following the point, the second point, and the third point is any point on the quadrant, the first quadrant on the xy plane. So basically, I would like you to set the ix, y, z same levels or the height same levels. If the user frame is not if you user frame doesn't have any kind, so otherwise if you set the third point higher than second point and the first point, it will make your user frame have the incline, and then you need to click calibration and then click OK. Let's see. As you can see from here, they're trying to generate the second point to the x-axis direction. And finally, they're trying to make the third axis because the plane there's an incline here. And click OK, you will see that there's a new user frame generating from here. So we can following this coordinate to move. User coordinate application. So basically, when we go inside the programming page, you will see that there's a two command: set user coordinate system and set user world. Set user coordinate system with selecting method. So basically on here, they will trying to show you the movement of the cobot without the user setting on here. Okay, the first one they will trying to input the user setting by manually input the data. And the second one, they input the data. So they try to prove that the result when you manually input the data or the result that you select the user frame that you made already, the input is the same. So here is some application that why we need to have the user frame. There's a 6 point here, there's a 5 point here, and then they're trying to move. You will see the cobot is moving. And then going up. The second one, the cobot will moving and going up. You see now the end fence didn't touch the point, but it's going up. Here's a method why we need to use the user frame. And here's some programming cases that you can try to learn by yourself. Here is a method how to do the stacking. You will see the robot position is have only one point and other is offsetting. And this is your first assignment. You can learn the software after you finish watching every video, and then you can try to come back here and learn what this software trying to do. Thank you. The next one is a method how to set the TCP. The TCP is this one. Why we need to have the TCP? In case that where there is no tools, we could only teach the robot pose around the center of the infant, so it means we need to refer to the center of the infant here. But if we attach the TCP, the tools already, we need to qualify, assign the TCP position at this point. Otherwise, so you can let the robot move easier. And here is method how to set the TCP. You will see that there is a tools. Opposite side of the tool is a Y direction, and then you can use your right hand rules to indicate it where is a X and where is Z. And coming to JAKA app, you will see that inside the setting, you will see XYZ, YYZ. And for the TCP making, there's a three method. The first one is manual input directly. So on here, you will see that the first method, they're trying to inputting the manual putting. The second one is trying to set the position for point. And the last one is trying to set the position 6 point. Here's a method how to manually input. So when you get the TCP to center point from your SolidWorks, from your hat file, then you can generate the position, the distance between the endpoints and the TCP. Then you can put it inside here. The next one is a full method inputting. As you can see from the picture that's showing inside the JAKA app, we need to teach the position by using the sharp tools to be the reference, and then move the cobot around the point. So we need to move around, then to make it quite close to the sharpened point. And then after you move around to the point, and then finally you will see that when we checking by the RC relation, you will see that the point is still being the same, only the rotation is changed. See, after this one, and click calibrate, and then click OK. And here's a method how to confirm the TCP. Go to the point, and then you select the TCP correctly, and then you're trying to move. The point will always be the same because your TCP has been generated. So when you're trying to rotating the point, so it will be the same. only the movement of the tool is rotating. And the last one is the 6 point. But on the 4 points, it's totally same, but it will giving you the Rx, Ry, and Rc. So here is method. I will go quite quickly. You can see from the photo inside there is a Rx, Ry, Rc direction. Here you see the point is totally same, but there is a Ix, Ry, Rc will be generated when you teaching the 6 point. So it means that if your tool is like the welding, it's required to teach 6 point. If your tool is like the only pick and place and keeper, it's required only teaching only 4 point. Caution for tool setup. In case of absolute accuracy is not required, we would create the TCP left instead, as long as it's easier for teaching. So it means that the purpose of the TCP when we want to move to the point is to help you to move to some points very easy. In case of exigent scenario such as a correlation with a in 2D with a vision 2D camera, all the robot must move in perfectly straight or circular path. In this case, we need to create the TCP tightly. During the creating of the TCP4 method, we need to ensure the tools and each point of the tool and is pointed to the point of 4 angles. Next, it's very difficult to get the TCP precise with the 4-point method if you don't have the flint quite sharp enough. Regarding the judgment of the TCP accuracy, after creating the TCP, take a reference object with the point and then you can try to rotate RC directions more than 180 degrees to see that there's any gap between your TCP point and the pin sharpened point. So you will see that if there is any gap, so it means your TCP accuracy is low, but if there is no gap, so it means your TCP accuracy is very good. If the TCP is not accurate enough by teaching 4 point or even 6 point, I will recommend to use the SolidWorks to generate the point manually and put the point manually. Application with TCP programming. So basically, it's the same with the user currently. There is a two types inside the programming. The one is setting TCP by using the TCP that we made. The second one is by inputting the data manually. So here is a teach you how to input the data manually, and the next one is inputting inside. Then we show you the result is totally same. Very good. Next. When you want to move the cobot, relative linear movement, as you can see from this commands, you will see that reference coordinate system, there is two types. The one is the TCP, the other one is user coordinate system. So we need to clarify it quite clear. Otherwise, the movement of the robot will be not correct. And pick with 2D camera. So here's method when we want to move the move the part. So here's a programming site on your left hand side. You will see it here, and you will see that they're trying to set the different TCP and moving in the same command. The first one, okay, move to the point. The one move to this point, and move to the point. Now it's correct. You see, one correct. So they will show you why it's not correct because the TCP and the movement is not correct. So you can see they are using the different TCP. So basically, if you have only one TCP, you need to use same one. TCP calibration. So it's just now I have informed you that when you want to clarify the TCP accuracy, you need to move the RC direction over 180 degrees to confirm that there is no gap between the TCP point and the pin sharp reference point. If there is a gap, so you need to repeat it manually. Adjust Y, adjust X to make it be accuracy. Thank you. I will let you try to understand the coding, including trying to make the TCP and doing the calculation by yourself. Next is the auto setting inside the setting. So basically, the first one I will show you is a trajectory record. What is a trajectory record? So when we want to make the trajectory record, so you can click here, start recording the trajectory, and then it will recording. After recording, you can move the cobot to the position you prefer. It will recording all the times of the movement. So you can initiate that when you want to do some application like painting application, gluing application, you can use the feedback cam and then move to the point, or even you can use the force sensor to move it manually to lock the axis and then move to the point. And after that, you will see the trajectory record. And coming to the programming, so you can drag it inside and then running the program. You will see the cobot wheel moving, following the movement that we have just moved. Change the robot IP names. So basically inside the setting, there's a method to change the robot names, including the IP address here. So we have two types. The first one is a LAN cable number one, which normally I will not let you using it. And the second one is the dynamic IP address, which you can click here and then you can type down what the IP address you want to use is a LAN port number two or the bottom port of your cabinet. Import and export. Import and export the profile. What is the profile mean? So it will keep all the IO setting, the TCP, the username that you made, the safety zones, and others like same variables. But it will not keep you the programming. So it means that if you want to change the controllers from the broken one to the new one, so you can export all the file first. After you export all the profiles, and then you go into the new controller and then you import first. And later you export the programming for the original controllers. By exporting the programming, you need to go inside the programming page and then click the folder here and then you're trying to export. This one is import. Then select the program you want to export and then you can get it out. And for the new controllers, after you importing the profile, everything perfectly, and then you reboot, and then you can import the program. Fault diagnosis. Fault diagnosis file or we call log files. So we want to try to monitoring every issue happening to the cobot. After we deploy the cobot application at the customer side, we need to confirm that the application we want to make the payload is setting and others like the speed is over the spec that we inform or anything that it will make the cobot broken. So we want to monitoring. Then if any error happen, it will generate the fault diagnosis. The purpose of this one is the cobot normally it will recording itself all the time to monitoring there is any issue happening to the cobot. And if there is, and then it will show out the heartbeat here, and then you can click stop to make it, and then you can send it out to the technical support to analyze. This is a problem right now we try to solve. So basically, when we move the cobot, okay, when we want to do the PM jobs, we want to identify the cobot is still functional, the cobot is still in perfect condition. So we need to going to record here and then moving the program robot like the routine side, so it will generate the sine wave. After it will generate the sine wave, and then you can going back here and then export to the laptops, and then we can try to analyze the data. The next one is the safety zone. So basically, what is a safety zone? Safety zone is will let you to protect like uh the walls, to not let the cobot going past through the wall, the pane. So here's method how to make the safety zones. So when you updating to the version 1.0.2, you will see this type of setting inside your safety zone, and then you can try to make it by yourself. The first point, the design 3 point, is same as how we made the user frame. And safety point is a point that inside the pane that you want to make. So you can we have the pane, and then you can come back, move the robot back to form the pane like 10 millimeters, something like that. And on here you can activate. You can activate. You can select protective stop, reduce mode, and others. And enabling, you want to activate this pane or not. And safety distance, if you want to increase the safety, you can put the safety distance like 100 millimeters, being the 10 cms. So it will make the panes closer to the robot. After getting the pane, you will see that the cobot cannot go out the pane. If it go out, it will stop. The tool orientation. Tool orientation is also the same, that you can make it to protect the human when working with the cobot. Here's a method how to do set is truly the same, and then you can see that we can limit the direction of the tools to not let the cobot like the cobot handling the very sharp tools, and then you don't want to let the cobot moving to other directions, then you can assign it from here. I will recommend you to try everything by yourself with the robot. Dedicated safety IO. Dedicated safety IO is very important for you to adjusting the collision levels, adding the emergency stop, adding the protective stop, or reset the protective stop here. So you can come on here, and then you can see that it's required to use the hard wiring method and double signal confirming, like digital input 1 and digital input 9 to confirm it for the output. You also can observe by yourself from hit this question mark icon. Thank you. Maintenance page. For the maintenance page, the purpose of having the maintenance page to release spec manually, multi-turn value, joint calibration. So here's the method how to go inside maintenance page. After you click inside, you can access the cobot, and then you can click the logo 10 times and then put the password JAKA missing. It will pop up this page. The first page is to release the spec. Normally when we want to release spec, right, you need to click this one, select join, and then select release spec. When you release spec, you need to move the robot manually by your hand and then rotate a little. Otherwise, if the pin is still locked with the base, so the cobot wheel cannot be moved and engage the base, so it means lock the base. When you want to release base from this page, you need to ensure that the cobot whole power is on, the robot must have the power, because when we want to release the base, right, we need to find voltage to the board. And on here we call multi-turn. Basically, for this one we will not do until we change the joint. So when we change the joint, sometimes it will show the joint is exceeds like 300 something, the joint is 200 something, joint 400 or even 1000. So we need to multi-turn down to be minus 360 to be less than 360. And finally, it's a joint calibration. For the joint calibration, from here you can click here to do the joint calibration, but normally we need to put the cobot at the calibration open port to do the zero calibration. It will make the joint become all zero. But on here and here, some joint is not the zero position is 180. So need to check the open port. And the next page is the H parameter, and the next page is servo debugging. The servo debugging is a page that you need to often use when you want to adjust the parameter inside the cobot arms. For example, you want to make the cobot uh, move faster, or you want to make the cobot move very precise at low speed, or you want to make the cobot not checking when you're moving, when you're setting the wrong payload, something like that. You can adjust it from the asset by servo debugging. And the next one is the robot limit. Normally the robot limit we will have the inside the safety setting already, but in here you also can assign the robot limit to be make the cobot be more sensitive. We will talk about the introduction of the JAKA cobot movement or JAKA cobot motion. So we will talk about the linear motion, joint motion, relative linear motion, and circular motion. The move out or linear motion. So basically, when we want to move the cardboard from point to point, you will see that we have the Cartesian data that I mentioned before regarding the user frame and TCP. So it will try to make the cardboard position movement line quite straight line. So it will be the straight line as you can see from the video inside here. But then when you want to use the linear movement, sometimes you will find the robot singularity issue. The robot singularity issue is the position that cobot cannot reach to the position that we design. The first picture from your left hand side, if you observe that the Z direction, the blue color Z direction from here, it cannot be moved because our joint is a six joint movement. You cannot let the end flange moving into the Z direction at the end flange coordinate. From the center picture, you will see that if you want to move the cobot into the Z direction, it's also having the same issue. You cannot make the cobot moving to the position that it cannot be reached to. The last one, as I mentioned before, the cobot in some position it cannot move past through the base itself. Here's the singularity situation that you may find using JAKA cobot or any cobot plan. The first one, move out or linear movement. When you want to move out the linear movement, there is a method to teaching the position. If you drag this one from the programming and then you click it, and then you can teaching the position. From your right hand side photo, you will see that there is a blue color and there is a robot red color here. So the blue color is a original position that assigned to this movement. The red color is a current robot position. So when you want to use the move out, please ensure that your orientation speed and your orientation acceleration is not very high, so it means that it can move it perfectly. If you put it 180 and put it 720, so it means that the acceleration of the orientation is very high. The recommended linear acceleration is below 1000 millimeters per second square. When you want to use the move out function, do you see that inside the command, there is a feature that you can select stop or bend. For the stop situation, it will make you stop to the point, but bend, so it means it will bend to the point. For example, from your right hand side photo, you will see that when you're moving from P1 to P2 and P3, the position will stop at the P2, but if you want the robot moving without stopping, so it means that you need to assign P2 at bend. Bend, I will recommend you to use at least 5 until 100 millimeters, so it can be very smooth, especially for using with cooling application or some application that it cannot be stopped. So here is some example to move to the point. Basically, when we move to the point and then when we running the program, you will see that the cobot will running around to the position that we assign, and the condition data will be changed all the time, including the joy data as well. But when you using the linear motion, please ensure that you have used the TCP and user frame inputting here first. Move joy or joy motion. Move joy or joy motion. Basically, when we want to move joy motion, you will see that there is a curve for the JAKA to move. So it means that we cannot control the movement of the cobot when moving. It will use anyway the arcs joy because the design is designed by joy. The movement it can be any angles. So it means that if the robot path planning design that moving this way is better, so it's be moving from this way to from this point to this point. So basically, when we doing the actual application, the position that we assign to be very precise, we normally use a linear motion. But if the position like move home to the home position transit point that we don't want to make it decision, but want it fast, so you can use move joint. Same things when you're using with the move joint. Inside the movement command, you will see that there is a point that you can use this point, use Cartesian position. So what is the use Cartesian position? Basically, when we want to use the move joint, it will refer to the joint data. So it means it will not care what is a x, y, z, I, or y, z. But if you take this one, so it means that it will following this data to be reference. And this data will be changed if you selecting the other user frame or TCP. And here is some example. So it will bend. If you put the bend here, you see that it will bend more. And here is some example of the joint movement. Relative linear motion. Relative linear motion, you can call it offset movement. What is the offset movement? As you can see from here, it requires you to assign the data inside. For example, if you want to move down in Z direction 20 millimeters, and then you can select this one to be TCP as we move down. And if you're using the baseball, and you need to assign this one minus 20, it means we move down. Note that you can choose the skip command condition when robot meet to this condition setting state. So at here you will see that there is a skip command condition. When the signal inputting to the robot, we can set the rules to make it skip this movement and going to next command. Same as other commands, you will see that there's a skip movement in every movement command. And here's some example. So basically, we move to the joy position first. We have reached the point. You will not see the book color. And then you select on here, you see that they're using Y into pass. And then the cobot will move following the pen. So on here you see that they're trying to do the square movement and then come back to home. When using the relative linear movement in the program, you need to pay attention to use currently tools or coordinate system, because at the program you will see that the commands let you select which coordinate system you want to refer with. For Sakura motion. So basically when we want to use the move Z command, we need to have the current position as P0, or we call initial position. So basically when we using this command, we need to understand that P0 is the first point, P1 is a midpoint, and P2 is the end point. So it means that before you moving to the P1 and P2, you need to have P0 first. And as you can see from the command, there is no P0, that point you can assign from here. So it means that you need to let the cobot moving to the P0, and then you use this command to let the cobot moving as C. And if you put 1 at the move left, it will become circle. And as you can see from here, the move C method, there's a many method that you can use: the minimum orientation change, the right orientation change, the midpoint orientation change, left mode, fixed orientation angles. So basically you need to understand which method you want to use. So as you can see, A is a P0 and C is a. So this video will show you how to move to the point. Okay, we assign some position first, and then we teach the position at the passing point, end point, and then we midpoint and end point. Then they're trying to select the move C method. The As you can see, the cobot will moving circle like this. So let's back to here to see what they actually did. Okay, they're using the move left mode 1-0. I will go next. The next topic we will talk about the variables of JAKA programs. Why we need to concern about the variables? Because every time we want to do the programming, you need to understand the basic structure of the variables, so you can understand how we can do the program efficiently. You can see, for example, the first one we call array, the second one we call num, third one we call string, and fourth one we call system variable, and fifth one we call speed variable, and finally we call position variable. So as you can see from here, when we want to use the command, only the this is quite long, only the system variable is global variable, the others is local variable. So it means that if we want to use to other program, you need to use only the system variable, and basically the system variable must be number only. And here's method how to create, delete, and variable setting. So basically, if you going to the variable tab, you can add and assign variable type, and then put the name, initial values, and then it will pop up like this. So the system variable, there is a symbol to be like this, and there's a symbol to be the local variable number normally. And variable settings, if you're using the system variable, you can assign from here as well to change the variable. So you change the variable from outside the programming. You also even can send the TCP command, the socket TCP command, to change the variable. Okay, starting from the first one, variable number. So basically, why we need to have the variable number? Here we go back. So here's method. We go back first. So this one, the video showing you how to make the variable. Okay, they want to assign the variable, so you can pass, you can count, and select one to be the counting, 1+1 until the design um, box size, box number. So on here, the next one, you also can put some stacking box. Velocity, you also can assign which speed. And finally, is the position, the location of the box. So I will go next to the point. So basically, when we want to do the palletizing, we can use the pallet initial position command, which I have not teach you yet. I have not taught you yet. So later I will teach you about the pallet initial position command. So, but on here you can observe that they set the initial position at 3 and the increase +1 1, so it will be count 4 times, it will be 4 times, and until the position number equally 9, so it means it will set the position number equal 1, and then it will let the robot moving to the assigned position, so it will be 1 if the position number reach number 9. So it will reset. Here's a method. Okay, so basically, and they want to assign, then move. I will go next. The system variable and program variable do not reset after program stop. Available for all program, only number type can be changed in the setting. For the program variable, it will reset after program stop. Available only the current program can be number array setting, cannot be changed in the setting page. And here is some example of the array. So what the purpose of having array? Array we can consider as a position as well. So it means that when we want to move to some specific point, like want to move L to point A we have keep the data by using array Cartesian data, right? X until RC. If we are using the join data, so it means join 1 until join 6. So on the other hand, it can be changed to each other. X or Y you can change by using the array's position. If you assign it correctly, you also can use it. And for this command, they will try to check whether what is X and what is Y to initialize which position we want to move to. If X equal more than equally 0 and more than equally 0, so if we move to A. And here is some example that I want you to try it by yourself as well. Set element names on here and try to set array. Basically array number 2. So it's still ascending to array number 2, pick up array number 2. So basically you can see that we can put array inside the linear position to make it as a position. And we can change the position as well to make it like the going to Y direction or Z direction, because it's as a subscript number 2. The starting is 0, 0, 1, 2, 3, 4, and 5. So it means it will be x, y, z, x, y, z, and then it will minus 20. Then it will move. After we looping, so it will deduce 20, deduce 70, and this one will paste, will add 20 in the Z direction. So this one is a toolbox tower picking up. So let's see. Let's assume that we finished programming already. So they want to try move to the point above pickup and then try to set the keeper to on off to pick up the work keys. Try to set array everything on here, and you can try running the program by yourself to see what is the output. When we talk about the arrays, right, we need to understand how we gonna change the value inside the array, because array is a component of many number. As you can see from your right hand side photo, the number is a 2, 5, 6, 36, 10, 80, 10, 96. So it means that from the index, we can call it index. Subscript starting from 0. So it means 0, 1, 2, 3, 4, and 5. So it means 0 refer to 256 and 5 refer to 96. So it means that, as said, subscript number 3 is refer to 80. And for this method, right, we can make it change. Number 3 to be 888. So it will be 1, 0, 1, 2, 3. As you can see, the 85 will become 888. Some example. Another command that we have the chance to use is array, start skip, and skip and stepping. This command will let you use for stepping the values of the array. For example, if we starting from 0 and we will end at number 5, and we assign the array position here, and stepping is 2, so the result will be counting from 0, 0, 2, and 4. So the data will be 2, 5, 6, 10, and 10. Another variable that we have this many chance to use is called string. String is a purpose that we want to print something it out to show the output, to let the user see what is the current output like, what is current position, and others. So when you're using this command, you see that we're trying to move to some points and then sending the data out something. So when we reach the point, we move to the point and then we sending the data out. So it will sending okay after running the program, because just now we assign the command here. Here is okay select R and select N. Select R and select S mean enter to step to another line. And next is a velocity variable. Velocity variable to set the speed of the movement of the cobot. So basically, when we use the every movement command, you can assign the movement speed individual into the specific command. But if you want to make it like a global velocity, so you can assign above the movement command. So after this line, every movement that you assign, after movement that you use is referring this global velocity speed. And if you want to use the default the speed inside each command, you can go back to default speed. Next is a position variable. The position variable normally is will keep 12 data of the numbers, or we call two arrays. The first array is Cartesian position data, and another data is a joint position data. So as you can see from here, we can try to edit the data. Even we can write down joy 320 or selection file. We also can write down from here and determine and do. Next is a IO function. The IO function, why we need to have this IO function? So we need to talk about the type of IO first. So if you are using the control cabinet, you will find that cap B, cap version 2.1, you will find that there's a 16 input and 16 input and 16 output, and it's all PNP type, full channel of analog. And on here you also can assign the name as well. Next is how we gonna wiring the signal input and output. We can try to see. And next is a minicap I/O signal. There's a table that you can understand where's a 24 voltage, where's a zero, where's a ground, and how to remote on the controller without using the remote stick. And 15 and 16 is for debugging, for internal debugging only. So it means that you don't need to use this 2 pin. So as you can see from here, the minicap is very special. You can assign the DAO to be input or output. If you select this one, you can assign to be input. And next is a TIO. TIO is tune IO. Tune IO, there is a female and male structure that you can see from here. Number 1, 2, 3, 4, 5, 6 to 8. Then there is a domain in your right hand side, which you can use for reference. So when we want to trigger the I and the O, so basically when we put the button, you will see that there is a function selection that you can select. What is the function selection? You may have doubt that how we gonna enable the robot, how we gonna landing the program. Here's a method, how we gonna run the program. Even though the productive stop you also can assign from here. I will go to next step to let you see what is the digital input trigger mode, trigger function. So basically run pause, stop, power on, power off, enable, disable, reduce mode level 1, reduce mode level 2, productive stop, back to initial, clear fault, free drive mode on, free drive mode off. As you can see from the trigger mode, you will see that there is a 3 function that using low level. What is a low level means? So it means you need to make it normally close, normally on. So it's, you need to on this signal all the time, otherwise it will be triggered. Why we need to do like that? Because this T signal is a safety signal, so it means it requires power supply all the time. It requires 24 voltage or it requires signals from the PLC all the time. And for the reduce mode level 1, so you can see that we can assign the speed, global speed of the robot to become lower than 100, like 70% and 32% in level 2 you can assign from here and click OK. This is a percentage configuration. And it's very important that for you to have the kill fault signal. So every time that you have the person alarm or something that you want to clear the fault before running to the next step, you also can trigger by the PLC as well. And when we want to do the starting programming, so you can select the default program like your main program, and you can select this button to automatically load the default program, automatically enable the robot when it's power on, when the robot is power on. So it means that when we supplying the power to the robot itself, it will automatically enable or release away. But this one I will not recommend you to, I will recommend you to not turn on this one because it will automatically run the program when the robot is enabled. It's very dangerous. And here's not how to another function for DO, the digital output. Idle program suspend, program running, error, power on, power on, enable, moving statics. Startup. Startup is mean controller have been startup. E-stop stage. E-stop stage. Idle is mean does not run the program yet. E-stop stage is for when we push the emergency stop and then you can send the signal going out. The robot reduce state, positive stop state. Safety position. For the safety position, It's very important when you want to move the cobot to the home position first, and then you can make the signal send back to the PLC after reaching the point. So what is your safety position? Your safety position is an initial position on here, initial orientation. So you can use with your data input back to initial position. And then after you send the signal to the robot, it will try to move to the initial position by this speed. And here's some example of the analog. So as you can see, when we talk about the Modbus, analog Modbus, integer, analog size, and float, there is some data type that you need to understand before using the protocol, other protocol. Expand I/O configuration. Expand I/O configuration. So basically, our cabinet, if let's say input and output is not sufficient for using, so you can expand to the expand I/O module. For example, Modbus TCP/IP, so you can make the cobot itself being the master, or Modbus TCP/IP and Modbus RTU, and then you can try to assign from here the IP address, the device ID, the port, and including the register address. And how come you can get to this register address? You need to ask the expanded I/O module supplier to give you the address table. That's why the Modbus RTU is also you also need to ask the expand supplier to know how to set the bus lanes, the stop bit range, data bit range, and parity method, and slave station number as well. And here's some example of the expansion board. So basically, our controller is currently the normal controller is PNP type, but if let's say you want to use the NPN signal input output, you also can expand the 485 to this device, and then you can try to connect it by 485. And after you finish connecting it, you will see that there's a 485B, 485A that you will try to connect, and there's a table will teach you which data type you want to use. And after you finishing, and yes, after you finishing the data, it will can let you controlling this expansion I/O. So it means there's a signal input output from here. You also can operate it. And here's a method how to expand the expansion board from the minicap. So for this part is we'll talk about the relay PNP type and then how we're gonna use, and I will not talk about it so deeply because it's not quite involved not related to the JAKA. We go next. For the next one, I/O instruction. I/O instruction, the commands that will help you to do the sequence, send the data, controlling the keepers, controlling the cooling, or send the data out to the PLC. The first command is we call set digital output. Set digital output, the next one is set digital output while robot is moving, when moving. So let's say if you want the robot to not stop when setting the output, you can use this command. So the robot will not stop when trigger this command, it will run parallelly. Await DI, wait until DI to be on. So this one you can see that there's a time that you can use. So next command will be wait until DI to be on. So basically this command, right? We have two options. The first option, we can assign the number as we want, one until any number that we want. Is we will wait until counting until the either the signal has come or the waiting time finish. But if you put 0 in here, it will be wait until the signal will be triggered. The next command is set analog output out when moving. So this command totally the same with the set analog digital output out. But analog output is mean setting as a number. So for this command, you need to confirm the data you want to assign to. For example, you're using modbus integer, modbus sign, or modbus float. So when you want to assign float into the integer, probably it cannot. If you want to assign -2 inside the integer, modbus integer also cannot. So you need to confirm the data that you want to send out. Next command is digital control cabinet DI on. So this one is for using with or if, using with if or calculate. To the result, you send back as boolean, true or false. Next command is set DO on or the. So for this page, we will talk about the command we're gonna use inside. Here is some example that you can use. You can combine the digital input with AND. You can use with a 0 or something other than this. The same things, you also can set the output, making it be like the next command is to get digital, get analog input or get analog output from here. So for this command, basically we will want to get the data from PLC or from IBC. We will receive back from analog. So here is some example of the command that we're gonna use. Wait until, and we also can use the 0 here. So we wait until digital electric keeper output cabinet the I1 equal on. So it will wait until it become trigger. And from here you also can observe that you can put the boolean condition and boolean condition here. The next command is analog. Set analog output. You also can get analog input to make the equation less than 100 or equal to 1, or you can use the if else if you want also to make the sequence here. But when creating using the analog input or output, you need to confirm that 16 bits is unsigned, 16 bit signed integer, and 32-bit floating point. So basically, that I mentioned before, you need to understand the data type that you're gonna receive or you're gonna send it out. Thank you. We go next to for this one, we will talk about the control instruction of JAKA robotics. The first two commands will be the set TCP to center point. As I mentioned before, the TCP is very important for you to moving and changing the Cartesian data. So it means that you need to clarify the TCP before using the JAKA, before running the program, and then set this command at the header of the program. And there's another method. You also can put array inside the TCP, so it will be set inside the program itself. So here is some example why we need to set TCP, because we need to use the reference to move to. And this is a set user frame coordinate system commands. So basically these two commands for setting the user frame coordinate. One is to assign the user frame manually, and second one is to select the useframe we have made. Same as the TCP commands, you also can assign the arrays variable inside the set useframe coordinate system, the manual inputting commands. So when you want to use a relative move in or move out, it can refer to your user coordinate system correctly. The next one is the payload setting. The payload setting is very important when you're using the pick and paste application, material handling, machine tending. So this command is required when you need to change your payload. When you pick up the path, when you paste the path. So on here you need to calculate the centroid. This data must include the keeper itself and the workpiece. And here's a set payload inside the JAKA programming, which I touched to you before. And the next command is a waiting instruction. The wait instruction, there is two commands. First one is a wait second. So you can assign how many seconds you want to make it wait until going to next line, going to next command, and wait until. Wait until command is a command that you can assign the condition to checking to make it wait until the condition is true, then it will running to the next command. Loop introduction and judgment introduction. So basically we have many loop type of the commands. The first one we call loop aways or repeat loop. Basically when we want to use loop away, we need to have end loop to stop the loop. And the next command is a loop number. So we can assign how many times we want to loop here. For example, we want to loop 4 times. If you want to step past something, so you can assign here 4 times. And you also can use the system variables here to put inside here. So it will referring to your system variable as a number. The next command is loop, if loop. If the condition is true, it will loop inside. So if the trigger has not been triggered, if the digital input one has not been triggered, so it means it will continue looping here. But if it triggers, so it will escape the loop. And end loop. This command I have mentioned before, so it need to use with the loops command. It will end loop out. So it means that when you moving to A, B, and then there is a signal digital input modbus on, it will end loop. So it will not work on moving to C and D commands anymore. And the next command is skip loop. So A and B, you normally you can run and then it will go to point A and point B. But if this signal digital input 1 has been triggered, so it will skip the loop and it will go back to move to A and move to B command. Not get out from this loop away. And if it's true, so this judgment instruction is quite simple. If digital input modbus DI1 equal on, so it means digital input has been triggered. So if it's true, then we work on moving to B and to C commands, but if it's not, so we will not going to these two commands. On the other hand, we also have the if else command. So if the same things, if digital input, if modbus digital input 1 equal on has been triggered, so it will move to B, else it will move to C, and eventually after finish checking the condition, it will move to D. Pause and stop command. And here you will see that we have pause and stop command that you can use when you want to pause and let someone to pay to resume the program, or stop program after we finish doing some job. Your right hand side command is log type message. This log type message to print out the data that we want to check around. But normally the data you can put it inside a string, so it means that if you want to get the current position or the numbers you need to convert it to be string before you pin it out. Next command is run program main thread and multi-thread commands. So basically our JAKA support multi-thread. What is multi-thread? Multi-thread is a software that is a process that you can run the program parallelly. When we want to using it, you need to confirm that inside the main thread or inside the main thread or the main program, you can use movement normally. But if you put the move inside the subthread, you cannot run the program. And as you can see from here, A, B, and then we will run the main thread. So it will going to another program first, program number 1, and then it will come back to C and D. And if you use subthreads, it will A, B, and then we run parallelly C and D. And the program will run the tower light simultaneously. Wait thread. The wait thread is very useful when we want to running and then wait thread. So on here, you will see that we move to A, B, and then we run the subthread tower light. So it means subthread tower light program and move to C is will running simultaneously. And the robot will wait for subthread 1 to be finished. So it will move C and then wait until subthread 1 to be finished. Then it will move to D. Destroy thread. Destroy thread is will destroy the thread that we use. For example, it's move to subthread 1 tower light, and then we move to 3, move to version C. At the same time, after it arrives C, and then it will destroy this subthread, and then it will move to D version. Test new text. It's totally the same as the subthread. It just made another thread inside the programming itself. So it means that A, B, and then we're running the program A, and then it will running here. The next one is calculation instruction. Calculation instruction. So basically, when we using the calculation instruction, we know that the number can be add, can be subtract, multiples, multiplies, division, or exponential. So on here, there is some example that you can try by yourself. So you can see the number doing something. And we also have the sine, cosine, tangent, arctan, arccosine, and arctangent. The data will be same as you want sine 30, so its data will be 0.5 here. What is the purpose of having this command? So sometimes we want to use with vision. It's required to use arctangent to get the position and then clarify the RC direction, something like that. Next, this command we always use uh, for making the condition to let it returning the logical commands to or for logical booleans result and or so not less than greater than equal to not equal to, and you also can combine the condition comparison calculator like this. The next command is quite useful is position calculation addition. This command is different between the first command that I showed you in this PowerPoint. This command is purpose of this command is to add the position. As you can see from here, we have P1 is 400 in X and P2 is 10 in X. If after you using these two commands, it will add 410 here, 510 here, 610 here, so it will add manually here, and then it will return, and then you can move to the point some point you want to go and subtract. We also do the same thing. 410, so it's equal 390 here. And there are small commands that you can use, but I will not explain in detail in every command because most of the command here we don't always use this command. So some command like this we might have chance to use, like calculate position distance. So it will calculate between point and point, then it will generate the distance between point and point to us in millimeters. And this command I think we might have a chance to use is we call interpolations point with coefficients. The coefficients you can consider until 1, so it will be 0 until 1. Let's say P1 is 400 and P2 is 500. Between 400 and 500 is 100. So if you assign here 0.25, so it will be 425 here. So it will generate the position to you. And this one we have a chance to use in some situation like vision application. The purpose of this command to add the data to the base point. As you can see from here, we have P1 equally 4x equal 420, y equal 420. So when we use this command and RC equal 40, when you're using this command, you will see that the result will give you 430, and eventually the RC is 50 because C axis rotation is RC, X axis transition is X, and Y transition is Y. And here's another command. It's quite similar, just only transform plane to YZ direction here. Next, we will talk about the subprogramming instruction. So what is subprogramming is, so basically when we want to add a subprogram inside our main program, you can add it from here, your left hand side. You will see that you can click add and then you can type down the name and even the use, and eventually you also can delete it if you don't want to use it. So basically we can classify the programming to be initial, back to initial, get item, or keeper close, or all keeper opens, check OK NG, something wrong. So it will easier for it to check back which line we want to use. So here is some example method. So basically when you want to copy the program inside here, you also can use it like this. Select here and then you click inside the copy, and from here you can click and then can hit here, and then you copy set here, then you execute to here. So you don't need to delete or rewrite the program by yourself. So you can copy it here. But the version that's supporting this kind of method is what to use 1.7.2 or higher. Then you can put here a subprogram between these two commands. Thanks. I will go next to the character. So basically this is a character instruction. The character instruction, the first command is string concat. String concat is through the purpose of this command to combine all the data inside to become a string. So as you can see from the example, select r select nb here, select r select n is equal enter. So we will not see select r select n here, but you see that it's enter to the next line, and then you can see b and code, and b value is a hello. Hello you also can put from here, and array eventually you also can see from here. String or array length. For this command is will counting the data inside the variable. For example, the variable b is hello. So it will count at 5. And variable C is 1 until 6. So it will count at 6. And eventually ABC, the string variable, so it will be 3 here. The string comparison. For this method, we normally use it for string 1 equals string 2 or not. For example, when we want to receive the data from IPC or PLC by the socket, you also can receive which program you want to run. Then you assign string here, the first one, string 1 equal 1 and string 2 equal 1. So if it's equal, so it will become 0. So you can know the return value is 0 when these two values got the same data. Next command is format output string format. So basically it's literally the same as string concat to format the output becoming string here. Even though it's coming from array, this array variable, and you also can assign array here and then select out, select in, same as I told before is enter. And then post J, and you can put the array data here and then close. The next one is we call input format string format. So what is the purpose of this command? This command is very important for you when you're using Vision or socket socket command that need to cut the data out. For example, if you receive end load is 1 until 6, these things will get end load is 1 until 6, but we don't want end load is one code, and then we just cut it out, and then we just want only post for being the position to let the ball moving to. So we can doing like this, and eventually we can get the post. Post is 1 until 6, array 1 until 6. You can see that we can assign from string change to be array. The next one is array to string. Just now we changed from string to be array, and this command for array to be string. Array to be a string, we can consider that when we have the array 1 until 6 here, and then we can use any separator. From this example, the using A characters here, and then it will be 1A until A6. Oppositely, string to array command, so it will convert string to array, because normally we want 1 until 6, something like this, but it's in string type, and then we want the array type to make the robot moving to. Then we can assign the string here and then assign the separator, which is comma here, and then it will make this data result output become 1 and introduction of socket communication. So for someone who has no idea what is a socket, the network socket is an inter-process communication protocol provided by the operation system. So normally this is one of the protocol that nowadays most of devices are using for exchanging the data to each other. So what is required to use with the socket? The first thing is required is a IP address. The second one is a port number. So we will starting from the first command, open socket. Open socket. So you can see that we need to clarify what is the port that we want to open. For example, we are using open socket number 1 bit IP address 10.5.5.121, and then port is equal 10,000 here. And another way to open the socket is use this command, but you can say that these two commands, the purpose of this command is the same, but for this one you will get the result back. So mean that if it can success open, so the result will greater than 0, but if y is fail, it will come -1. When you open a socket and if you don't want to use the socket anymore, then you need to close it. Otherwise, you will repeat the opening socket again and again. And here's method to open the socket repeatedly until it can be connect. You can see that if repeat, so it means that it will open until the socket result more than 0, and it will get out from this loop. But let's say if it becomes 0 or it's less than 0, it's -1, and then it will repeat loop. It will always repeat. The send data command. So basically, this one is purpose of send data out from the JAKA to other device like PLC or IPC or camera to take the shot. Let the camera taking the picture or command the tools. At here, you can assign anything you want, and then data that sending out will become string. And when we want to receive the data and to know that can we send it out successfully, so we can use this command with result. So it will be the same if it equal -1, so it means that it failed to send it out. The next command is receiving variable waiting time. So for this command, I typically not use this command, but I will explain you a little bit. For this command, it's quite not convenient to use it because you need to assign the actual variable names correctly. For example, you want to get the data from PLC side not need to assign A and 111, and then server need to assign like this, and then it will receive. Otherwise, it will not receive. And you can look it by yourself here. Because when we want to use this command, right, we need to use the syntax correctly. Otherwise, the data that we receive, it will not correct. It will not be correct. This command I have a chance to use is socket receive array length waiting time. So basically, this command we want to receive array to array. You can see that the program variable C is array, and then we want to receive array including 6 number, so it will be received from the server. And this is command that I always use. Socket receive waiting times. Socket receive waiting time. The normally waiting time, you can see that if you put here 10 seconds, it will wait 10 seconds, and then it will going to the next line, the next command. But if you put it as 0, so it will wait until something have been sent from server. So it means that B is a string, and then it's clearly waiting some data from the server coming to B. Because when we using this command line, it typically becoming string, so we need to use string data to be here, and then later if we want to convert to the position, we need to convert by the command that I teach you before, the convert string to array command. And here is some application that we can use for doing it. As you can see, we have some software to make it robot, make it become like a server, and then make the robot to connect to the server here, and then we will trying to move. You see, and it's still trying to move here by assigning the position here, because you can see that we receive as thing and then we convert as a post, and then we can move the type to the post and then send back okay here, you see, and we can repeat loop like this. So later, if you have a chance to use the JAKA cobot, after finish training, you can try it by yourself here. And here is a Hercules socket debug tools. If you want to learn about the socket clearly, you need to have this software. So technically, if you want to open the socket, you need to understand what is your TCP server, and then when you open the port 10,000 here, and then you can click listen. So you can let the robot connecting to this uh, virtual server QList, and then it can send the data here, make itself as the PLC or IPC. But please turn off the network firewall, otherwise the communication might be lost. The next topic we're gonna talk about is interfacing with PLC. So basically, when we want to communicate with PLC, the first thing that we need to understand is this one, the material, the JAKA communication manual here. So every PLC that you can imagine it is we already have the manual here. So you can come and try to check around. And inside this manual, you will see that we provide you the XML file for Fortinet, EDS file for for Ethernet IP protocol. And if you're going down, you will see that there is some instruction for from robot side and PLC side to make it can be connect. And if you're going down to this page, you will see that there is a table data register for the Modbus address distribution here, the Profinet and Ethernet IP distribution here. You also can check it from here. Okay, and when we come back to this page, so the first thing, what is the Modbus? For someone who don't know what is a Modbus, what is a Profinet, what is the Ethernet IP? Basically, when we communicate to the PLC, nowadays we using the Ethernet IP or EtherCAT, but someone also use Profinet and some also use Modbus because we can use the LAN cable to connect to the robot without using hard wiring. So it means that we can save time, we can save the signal for other purpose at the front panel of the JAKA controllers. But here, Modbus is a serial communication protocol developed for the PLC. Based on this protocol, you can communicate to each other. So when we talk about the protocol, you need to understand what is the master and slave. So when you want to talk about the master and slave, so here the JAKA robot is compatible with Modbus RTU and Modbus TCP, but for the Modbus RTU, we can be only master, we cannot be slave at the moment. So basically, when we want to operate the data between the robot and PLC, you need to understand that there's a 1 and 0. 1 is mean trigger, 0 is mean have not been triggered yet. So we can call 1 is on and 0 is off. And you can see that number of coil and resistor has been put on here, 1 until something, and here's a data address, type of the data, and cable name. So if you have experience using the PLC before, you will understand that what is the discrete output, discrete input, analog input, and analog coding resistor. So what is the slave ID? Each of each slave will be assigned a unique address from 1 until 247. So you can select which ID you want to use, and then master will send the data to the slave. And from here is a behavior of the function code. So basically we provide you the table of the Modbus, TCP and RTU, and then the data itself can be sometimes is need to be the polling register, sometimes it need to be input register, input coil, discrete input. You need to check from this page. So as you can see from here, the first data is 8. it address 8, and the register type is discrete input, readable but not writable, but not readable. So you need to assign inside the PLC like this. And for controlling the digital input of the JAKA cobot is 40, and this is called step. And if you want to get the data from JAKA all the time, you also can tracking from this data, like the joint current, the Cartesian, the TCP position, the joint speed, and others. And it will generating for by using the input register readable with the specific IP, specific register table. So basically from here, TCP is Ethernet cable connection. The forward file is B and A connection here. So you need to use the hard wiring to connect suitable for poor working condition. So it means that some device is very old. It need to use 4.5, but typically device nowadays is can use TCP or socket communication already. And here is method how to make the robot being slave. So if you coming at this page, you will see that you can assign the port because you need to assign the IP address first, and then you can assign the port. And at this, you also can assign the modbus ITU slave number here, everything's here. And here's a video for Modbus TCP communicate case with the Modbus pool program. So you can see we assign 0.02, and then we try to communicate with the Modbus here. And then we use this program. I will attach the link, and then you can download it. And you can connect to the Modbus to the robot. Then using the server port as generator. Then we connect already. And when you connecting it, you can go into the setting and change the type of the data to be discrete input, and then change the address, the starting bit to be 8. So we can try to apply. And on here, when we trigger something, you will see there's a output coming here. See, and then we can use this data to track back. I would like to recommend you to try it by yourself with this software. And at here you will see that if you select fit to quantity here, it will apply the data like this. So it means you can trigger, yes, trigger from the Modbus pole to the robot like this. You can assume that this software is a PLC who controlling the JAKA robot. So you can send and receive the data by using Modbus digital input, output, or Ethernet IP and Profinet. And there's a Modbus table that you can assign. And here's some example of the how to get the fault, how to get the sign here, and then we can assign some data out. Okay, when we want the fault, so we will see that the data is here when you assign something. And okay, this data coming out here. And this method to write down the data, you can see to 1, 2, 3 is right down on the here. 4, 5, 6. For Modbus TCP as a master, inside the JAKA app, you will see that we can create to let the robot being the master to controlling some specific device like a pension board or keeper or or welding machine or other device or tools like keeper, and here's method how to create the Modbus TCP master inside the JAKA program. So you can see that we will try to make it as a slave. Now currently we open the Modbus slave, then we open the socket first, we open the port, something, everything, and we trying to here, and then we trying to set up, preparing your device, and then from here you also can assign what is your name and what is your IP address and port you're going to use. So at here you can see it's over 0, and then how many variable it can up until 64. Then you can see it can communicate now. So basically it's this totally the same with the Modbus TCP IP, only you need to set up the bus rate, stopping bit, data length, and parity method to be matched with the device, because some device need to assign first, and then you need to let the robot connecting to the device like the DH keeper, also connecting by the Modbus ITU at the front panel of the controllers. And here's some Modbus slave address table that I talked about. So the starting bit is 8 for the digital output, and this is right on is DO1, something like here is DO1, and here's the starting bit is 40 and coil state here. And this cell table you can checking inside the website that I showed you just now. Ethernet IP communication. Before you using the Ethernet IP, you need to activate first. It's not the same with the Modbus TCP, Ethernet IP, and Profinet. You need to activate first. For activating, you need to come to this page and then click activate here. Then you will see this page. Coming to this page, right? So you can assign, and then you can mapping the data from the PLC side, and then do everything the same as the Modbus that I show you. But because we don't have any Ethernet IP simulation to show you, so we connect to the mod Profinet. Profinet is the same thing as the Ethernet IP. You need to activate, enable it, and reboot, restarting the robot, and then it will become activate. Next one is a palette instruction. For this command, it's very basic for you to learn how to use it, because when we want to do some stacking, either stacking the part, when we want to do some 3-dimension stacking, so you can come on this control function here, and then you select this program out, and on here they want to teach the position first at home, and then put the palletizing here, and at this line you will see that there is a palette type, which can referring to how many dimensions you want to use, 1 until 3, 1 until 3, and then you can count from point 1 until point 2, and then you can teach the point here. So from the example, they are trying to teach the point, and after teaching the second point, something like this, and then they will use a relative limit motion to move it down, okay, up and down, something like this. So it will be like this here. And as you can see, when we running the program, why is running only one times? Because we want to run it many times, right? It palletizing. Because we need to put the loop here. After we assign the loop, accordingly to the number we put inside, like we put inside 5, then we put it here 5, and then eventually it will looping like this. Move to the second point, and then move to the second point, and then up, and then up. Let waypoint. So just now the example show you that you can use the relative movement with the palette tracing command, but in the specific case you can use a palette waypoint to let you teaching the question referring to the first point. So basically you can use this one as a down and up. And because this one you need to assign the number here, you see, when we teach the point and then we select this one, we need to click here and then select here and then assign the number. But for this command you can teach the position you want to move to, and it will stacking by itself. Okay, so the first thing, we select 2 dimension, how many point from 1 until 2, how many point from 2 until 3, so it's totally 4 point. And they're trying to teach the point. Okay, they're trying to teach the point 4 point. Accordingly, 4 point refer to this. You can click this button and teach the point. And then you use this command for the waypoint. So this command you can assign like the going down or going to this way. Okay, so we move to this point and then we teach the point. Okay. So it's purifying the waypoint offset from the palletizing, and then we move down automatically. You can see the result here. Every time you're running the program inside the JAKA app, it requires you to move the initial position first. Confirm the safety. You see the robots moving to the here and then moving to some point. And up here, they will assign 100. For avoiding uh, manually moving before running the program, you also can do like this. Go back to home every time. So you can see it's still moving to here, and it will move following the waypoint that we made. And here's a next method for the square. This is a 3. You can see there's a username here, and then there's a t times 3 9 point that you can assign, and then they're trying to assign the 9 points here and use only this command to looping. Okay, to the first point first. This is a down and up. So it's been moved down and moved to the point. So here is a going down and going up. So we teach the point from the first point, referring to the first point, and then it will automatically generate.